below. All right, so today's lesson. Today's lesson, a little review from yesterday. Recall, we have a battery. Recall, obviously, again, the positive side is here. The longer side, I'm not going to draw that, but just remember that. Come out, come to a resistor, maybe another resistor, and then we go back to ground. Again, for those of you who weren't here yesterday, remember we say it goes to ground. We connect a negative battery to the frame of the car. So we say frame, but honestly, that's a bit of a misnomer. So you might have a subframe, but everything on the metal in the car bolts to the quote-unquote frame of the car. Therefore, everything is connected to the battery in that regard. Okay. So again, we run our current through here, through our two light bulbs, and then we come back and we just touch the frame. Ta-da! We're connected back to the battery. Your frame, again, the rest of your car is the other wire, if you will. So we chatted about this the other day, so just a quick little review here. And this is a series circuit because you must go through them in a series. You got to go this one and then the second one, and then yay, there we are. So we get 10 ohms, 20 ohms. Sweet. That is a total resistance of 30 ohms. And again, my boy Greg Ohm, he said V equals IR. So you divide by 30, and you get I is equal to, wait for it, keep waiting for it, Groom's got you. Oh, bam, 12 divided by 30 is 0.4. I should have seen that. Duh, 0.4 amps. Or if you prefer, 400 milliamps. Yay, Groom, that was so easy. I feel so smart. Well, now you should feel smart. Good job, kid. Now, let's do another one here. And of course, we mentioned this also yesterday. This is a nice little review for us. Nice. Oh, dude. Is that one of those ones where, whoa, it's like this top side is parallel to the bottom side. Wait, this is that thing that you said if we're trying to get from A building to B building, if I put in another hallway, guess what? There's less resistance to flow. Therefore, there's going to be what? That's right, kids. Less resistance, more resistance. Less resistance, more flow. Duh. Okay? And so that's the idea. So if there was only one hallway with 20 ohms of resistance, then we can only get so much current there. That's lovely. But now I've got two with 20 ohm resistance. That means the total resistance is half of that. Again, this has to be this way on a car because it's going to be things like light bulbs. Okay, if I had one light bulb that had a higher resistance and one with lower resistance in a parallel circuit, the one with the lower resistance would burn brighter. And we'll see that tomorrow, yeah. Probably Friday, we'll probably see that. And for sure next week we'll be doing some labs. And in those labs, we'll be looking at that. We'll be going, I'll be darned. Did you know, Groom, that if I had a 10 and a 20 and in parallel like this, that the 10 would burn brighter? Yeah, I did know that actually. Wow, crazy. But that's not true in a series, but we'll find out why as time goes on. So again, the total resistance is 10 ohms. So again, Ohm's law, 12 equals 10I. Oh, look at that. Shut up. So I is equal to 1.2 amps. Now remember, that's the total current. So 1.2 amps here, baby. 1.2 amps here, baby. 1.2 amps here. Nice. But when it gets to the fork in the road, we're going to have what? Well, they're identical paths, so half should go one way, and half should go the other way. That's a parallel circuit. Now, the thing to remember on a parallel is on the two parallel branches, or two or three or whatever parallel branches, the sum of all those currents has to equal the total. So 0.6 plus 0.6 is 1.2. Now, on the previous page, on the series, Hey, there was 0.4 amps of current. Was it here? Yep. Was it here? Yeah. Was it here? That's right. Because in a series, the current is the same everywhere. Okay? The current is the same everywhere. What's not the same, it's not, but it's not true in a parallel circuit. In a parallel circuit, it splits up. Okay? 2 ways, 3 ways, however many ways it happens to be. Now, again, not very hard. I think you'll find it to be fairly straightforward. Now, the thing I want to introduce today, and I don't want to do a ton today because A, it's a short day, and B, I'm not here. But I do want to look at this for a second. So I want to talk about we are going to be looking at what are called voltmeters starting on Friday. We're going to do it a bunch of times. And these voltmeters, we're going to refer to them as DVOM. Sometimes I'll call it a voltmeter. Sometimes I'll call it a DVOM. Sometimes I'll call it a meter. Irregardless, there it is. So, digital, volt, ohm, meter. DVOM. So it's digital. So I have a little digital screen here. Awesome possum! Now next time, when we come in, you're going to see one that's going to look like this. It's going to have a straight line on it. That is DC voltage, direct current. That is, it moves in a direct line. We will not talk a lot about AC, but we will discuss kind of how they're different. We don't deal with AC in a car. That's kind of a lie. We don't deal with AC in a car except for the alternator. Internally, the alternator has an AC signal, an AC electricity. We convert it to DC before it comes out because we have a battery. Anytime you have a battery like this, that's DC, direct current. Okay, so we're going to set it up that way. And then what you'll notice on our meters is there's going to be one that literally says common. And it typically has this little signal right by it. Oh, that's ground room. That's right. And we're going to put that guy with our black lead. Now, if I were to come over and touch the post on my battery right there, nice. And I'm going to go ahead and change put my red lead here with the red marker. And I'm going to drag that puppy around and I'm going to place it right here. And when I do that, I'm going to see 12 volts. Well, assuming this is a 12-volt battery. Okay. Piece of cake. Easy money. Aight. Nice. Now, I want you to stay focused with me for a minute. Everyone see that? It's pretty easy to do. Okay. Now, I'm going to leave the red one alone for a minute, okay? I'm going to move the black one. Now, I want you to tell me what you see here. If I move this black one, oh, what in the hell? Go away. If I move the black one from hither to yon, Groom, you took it off the negative side of the battery. Oh, did I, friend? Did I? No, I don't think I did, babe. Here's Ed the electron. He's our dog, man. He's an awesome dude. He doesn't have arms. He's a freaking electron. Can he see, from right here, can he see the battery? Well, yeah, he sure can, because this is what? It's connected to the negative side of the battery. And what's the meter going to say, friends? 12 volts, Groom. That's right, kids. 12 volts. Nice. Nice. Now, you may recall that day one, I told you that when I was a kid, they told us that volts is like a waterfall. It is how high the water is. Okay? So if you have water up here, what does it got to do? It's got to come running down the hill. Yes? That's what water does. Mr. Groom, I see a puddle in the flat driveway outside. It's a puddle of water. What do you know about that? That means that piece of ground right there is flatter than a fritter, right? And there's no flow. You with me? It's not flowing anywhere. It's not moving. If this hill was sitting like this, and a feller poured some water right here, down the hill it comes. Why? Because gravity. Okay? Voltage is the same way. Okay? So if I were to take my voltmeter here, boop, 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 and I were to put this fella at the bottom, let's say, the black one that is, the common one, and I were to take this guy here, And again, what I'm measuring is, this is the positive side of the battery, this is the negative side. And I were to measure that, I would get, again, 12 volts, right? Or I would get battery voltage, whatever the battery voltage is charged up to be. It's pretty easy, right? That's what we just did a minute ago. On both of those examples, we went from positive battery to negative side of the battery. Easy, groom. Now, question, what would happen if you had this? Bloop, bloop. It's like two waterfalls, groom. Dog, I know, right? So check it out. Check it out. Check it out. Here's my meter. Here it is. Check it out. Again, volts. Nice. Put this one up on top because that's, again, my positive side. And grab this cat here. Bloop. Negative side. You with me? And what should it read? It should say 12 volts. Because that is, if you will, the height from top to bottom. Well, yeah, duh, groom. This is not hard. Okay, friends. You people who are like talking smack. What if I put it here? Well, it's not 12 anymore, groom. Well, what do you mean, bro? Because it doesn't go all the way to the bottom. Like, it might go halfway to the bottom. So it's going to say 6 volts. Well, we say this is a, check it out, from here to here, this is a 6 volt drop. Or if you will, is the voltage drop is 6 volts. Okay? That's another way of saying that. Okay? Well, if it was 12 from here to here, and it's 6 from here to here, then obviously this better be 6 as well, yes? Nice. And again, we can do that. Bloop. And, oh, I gotta move this one. Bloop. Now, we will get to play with these meters so much, you'll be like, groom, let me do it some more. And I will say, no, you've done it enough, crackhead. When you put the red one to the positive side, it will say positive. If you switched them around, because you're weird, and you put the positive one on the negative one, oh, it's going to blow up. It's not going to blow up, dog. Just calm down. It's going to say negative 6 volts because you're measuring it, quote unquote, backwards. Does that make sense? Now, why would it do these different drops, groom? Check it out. Well, in our what we've been talking about in our circuits, this would be a resistor here, and then another resistor here. Oh, dude, it's a series circuit. It's 100% a series circuit, dog. And the total voltage drop from the positive side of the battery to the negative is 12 volts in this case, yes? So if it drops 6 across this resistor, it's also going to drop 6 across this resistor. Well, how do I know, groom? It seems so hard. It's not hard, babe. I got you. I got you. I got you. Now, here's my question. Suppose my boy Ed is hanging out in here. See, he got taller all of a sudden. I don't know. Can he see back to the battery from here? No, because this stupid resistor's in the road. That's annoying. Oh, what? So if I measure from here to here, I will not get a 12 volt drop. It might be, like in the case of the one we just did, it might be 6 volts. You with me? This one here might be 6 volts. Okay, 6 plus 6 is 12. This one could be 8. Oops, 8 volts. If that one's 8, this one has to be 4. Trivia question, could it be 16 volts and negative 4 volts? No, crackhead, they can't have a negative, you weirdo. You also can't have 0 volts. That would be weird. But you could have 9 for, oh, damn it. Stupid computer. Pardon me, friends. Click here, reload my page. Thank you. This one could, for instance, be 9 volts. This brings me back to the scamdemic when I had to sit here and talk to myself. This is kind of creeping me out, to be quite blunt with you. That could be 9, and that could be 3. Well, groom, how am I going to know? Okay, oh, by the way, if this was 9, where I have it currently, this would say 9 volts. You with me? That would say 9 volts based on where I have it. And then what if I moved this black one over yonder, bloop, and the red feller, bloop, this sucker would say 3 volts. Dude, But how would I figure that out without a voltmeter? Oh, I'm glad you asked, dog. Glad you asked. I don't want red. Yuck. I hate looking at red pen. It annoys me. And not because I'm triggered by it, just because it annoys me. Black and white, lots of contrast. Now, I'm going to do a nice easy one. Oh, I'm going to do 10 and 10 because I feel like it. Groom, they are the same resistance. Will that mean they will have the same voltage drop across both of them? The answer is yes, Mr. Groom. The answer is yes. But how can you prove it to me? Let me help you out, babe. The total resistance is 20 ohms. Am I right? I feel like I'm right. So my boy Ohm said this. Dude, check it out, dog. I is 0.6 amps. Okay? Now think about that for just a second. Look at it. Look at it. Okay, now 0.6 amps flows through this thing, yes? Look at it. But check it out. V is equal to I times R. But the current is 0.6, Groom. It sure is. And the resistance is 10, Groom. Oh, it sure is. Hey, that makes 6 volts of voltage drop. That's all I got to do? Dog. If this one's 6, then this one over here has to be 6. Will that always be true? If they're the same resistance, will they have the same voltage drop? The answer is unequivocally, every single time. You better believe it, pal. Take it to the bank. Okay? Now let's try another one here. Aight. Look at me. Yo. I miss talking to you people in class. It's not the same. I'm sitting here in my chair. Quote, working from home. Except that I'm actually working today when I'm not with you people. Okay? I just happen to be doing something key with Mr. Mock. 2 ohms. 6 ohms. 10 ohms. Total resistance 18 ohms. Am I right? I feel like I'm right. So 12 equals 18I. And say I is equal to, well, 2/3, which is 0.666666666. Repeating, I amps. Let's have some fun, baby. If it's me, maybe I do this one first. V equals 10 times 0.66666. And so I'm going to get 6.6666, repeating, volts of drop across that resistor. What about for this guy? Well, all I got to do is take 6 times 0.66666, and I get basically 4. Well, it's not basically 4. It is 4 volts. So 6.6 and 4, that's 10.6. Am I right? I feel like I'm right. It's 10 and 2/3. That means this one here has to be 1.333. Repeating. How do I know that? Well, again, the math says to take 0.6666666 times 2, and it comes out to be 1.33333. Repeating. Hey, that adds up. This plus this adds up to 12, as promised. Okay? That's easy, huh? Nice. Okay, now, what about in a parallel circuit, Groom? I'm sorry for the snorting. I'm dying, apparently. Stupid nose is plugged up or something. Sounds like a personal problem, Groom. Yes, it is a bit of a personal problem. Thank you for mentioning that. Suppose I have my voltmeter thusly. Bloop, bloop, bloop. Check it out. Boop. Check it out. Oh, gotta get the right color, Mr. Groom. You're gonna freak everybody out. The children are expecting a red wire, Mr. Groom. Boom. Dude, can my meter see the positive side of the battery directly? Sure can. Can it see the negative side of the battery directly? Sure can. 12 volts, baby. Done. You with me? 12 volts right now. Right now. But wait. Doesn't that mean... Wait. But. Doesn't that mean the same if you had to put it right here? And right here? It sure does, baby. 12 volts. Whoa! So in a series, the current is the same everywhere. In a parallel circuit, the voltage is the same everywhere. Okay? What is this guy? Voltage across here? 12 volts, baby. What's the voltage across here? 12 volts, baby. It's that easy. It's that easy. That easy. Okay? So, like, you're like, Groom, do I have to figure out the voltage drop on a parallel circuit? Not really, no. Because if you're standing here, if you're standing like right here, here's Ed, you look in this direction, I don't know what he's doing, sticking his tongue out, I guess. Can he see back to the battery positive? He absolutely can. If he was on the other side, could he see back to battery negative? He sure can. So what does that mean? If you put your leads here and here, they will say whatever the battery says, 12 volts. And that will be true every single time. Okay? Now, I don't want to do that yet, so I'm just going to do this. Let's say this was 100 ohms. 100 amps. I mean, the total would be what? Total resistance is 50 ohms. I'm going to die. 12 divided by 50. 50 cent, yo. 0.24, ain't it? Yes, sirree, Bob. 0.24. Okay, now this is important. Are you watching? Are you watching? This is the total current. 0.24 here, yes? 0.24 here. Nice. But how much goes across the top? 0.12, 0.12, right? Now, what would the voltage drop be across this resistor? Well, V equals 0.12 times 100, which is, wait for it, 12 volts. Yay! So on the assignment today, which is going to be very straightforward, I'm going to be drawing you some circuits, whatever. Find the total resistance. Yay. Find the total current. Yay. Mr. Groom will ask you, what's the current in this portion of the circuit? Yay. Mr. Groom's going to draw you a picture. Like, what does this represent? Ground. I don't know. Whatever. What does this represent? I don't know. Whatever. Resistor. Duh. Whatever. We did this the other day. What does this little fella do when I draw him in the middle of a wire? Hey, that's a fuse. Duh. I can ask you all manner of questions like this. I don't know that I will. But whatevs. That's what the assignment's going to be today. I'd like you to turn in a class before you leave. I'd like you to. I can't force you to. This is America. You're still welcome to fail. God bless you. You have the right to fail. Nice work. I will not stand in your way. I will stand behind you and rip you a new one if you try to do it. But I can't make you do it. You with me? I got you. Peace out, homies. I will see you next time. I do miss you.